Testing 1, 2, 3. I've had to do this video twice now, so let's hope we get through it this time. What we've got here is a circuit that's very similar to your homework. Very similar. I've got new values in there, so you'll be able to be successful if you spend a little time looking at this circuit. What appears to take 20 minutes to teach you takes a lot longer than that to prepare. Sometimes 1 to 2 hours for one problem to be posted online. Anyway, enough complaining. This circuit has two current sources in it, a 1 amp and a 2 amp. And I've labeled one of them IS1 and the other one IS2, as you can see in the drawing. I won't go ahead and just drop a bunch of stuff in there for you at this point. You'll notice that this supply, IS1, flows down in the direction of the red arrow. And it flows down through R2 in the direction of the red arrow. And it flows down through the load down in the direction of the red arrow. Now, that being said, what I'd like to do is look at the second source that's out there. And what you'll see is that the second source flows down in the direction of the black arrow and down in the direction of the black arrow and up in the direction of the black arrow to the left here that I've drawn in. And that means that there's going to be some opposition on that resistor R1 because they go in the opposite direction. And I've already gone ahead and marked here that R1 opposes, R2 appears to add, and R3 appears to add. So our only place to make a mistake is right here at R1. But I have good news for you. The good news is that this problem and several of the problems in superposition are a little simpler than appear to be. When you go check your homework and you have to work one like this, what it's going to tell you in the homework is they only want to know the current through the load resistor because of the two current sources, which means that we don't need to build 3 equations, although I did for practice. To give you a chance to see it again, I did. And also, take note, 3 parts, 3 equations. 3 parts, 3 equations, okay? Because each one is the result of a different source. This particular block is the result of IS1, and this particular block is the result of the second current source. So you're going to have to do this twice because there are 2 sources. But here's the good news. Theoretically, in your homework, they're only asking you to find the information for this. So even though I drew 3 equations, in your homework you only have to draw the 1 equation and solve 2 currents. We're done with everything. There's a 0 here. There's a 0 here. There is a 2 amp in that spot. That was blazing fast. What are the odds that this row, this column, takes any longer? And sometimes that's really easy. So, that being said, I'm going to solve all of them anyway for fun, just to go through the ritual. So, I've shown the drawing here again, and realistically, again, we're just looking for the current through this resistor, but we're going to find all 3 of them because interesting things crop up when you are playing with current sources. We opened the load here in this position. We opened it, and that means something special. That means that you are not getting any kind of current coming through those resistors. I know it's hard to believe. I know that. But remember, a current source has a large input impedance. A large input impedance, which means there's a lot of resistance there. That supply is blocking current flow to those two resistors located on the right. As such, there's no current there. Wow, that blew me away. Now, that also means that this resistor over here is the only resistor that's getting 2 amps. Wow. Wow. No real analysis. Look at the numbers. This is insane. We're done. We're done with the first complete loop, okay? Probably not much. Probably not much. Okay, so let's wipe the board clean and let's go to the third drawing here. And in the third drawing, we have opened up the first source. And you can see that by opening that first source, this current source here flows down and down and around. So R1 actually gets 1 amp. It actually gets 1 amp. Of course, we don't really need to worry about that. This problem was geared towards finding the current in the load. Well, the current in the load is split amongst two 4K resistors, and if it wasn't, you would have to do current division formula to figure out the split. But they're identical. They're both 4K. Therefore, you get a 1/2 amp coming through each leg. Wow. Wow. 1/2 amp in each leg, 1 amp in the first resistor. I didn't even break an equation out. This is amazing. This is amazing. So, in summary, let me summarize here and clean up the board a little bit. In summary, you didn't need to do much of what we did. These two lines that are shown right here with the red line running through them weren't really required of the homework problem, nor of this problem, but I set the equations up. If you want to finish them, you can plug the numbers in. Here they are, 1, 2, 3. They fill in this box right here. And so to answer our question or to answer our homework problem, the answer to our homework problem is that 0 plus 500 milliamps flows through the load here. As problems get harder, you are only going to be asked to find certain things like 1 voltage, 1 current, somewhere in the circuit. Otherwise, the circuit becomes unmanageable. Hey, I have a question for you. Well, you have the current through here. You have the current through here, right there. It's 500 milliamps. What if I wanted the voltage here? Would that be hard for you? Because if it is, you better look at this. V equals IR. I have R and I have I. How hard is it to find the voltage here? 500 milliamps times 4,000. That's 4 times 5. That's not too bad. That's a half of 4,000. That's calculatable, right? 500 milliamps times 4,000. That's a half times 4,000 gives you the voltage. So I bid you a farewell. I wish you luck in your superposition circuits.